important skill in lots of math class, and especially in a class like 251, is knowing how to check your work, knowing how to tell if things have gone wrong or something like that. So in this video, I want to look at some of the mini quizzes that we've done so far. I'll have the keys posted at Canvas in the very near future. I've got the keys posted, keys sitting here, right here. So what I'm going to do is I'm going to assume that you've already have completed the problems and just show you a couple of tips to kind of check your work when you're done. So the first one I want to look at is the second problem from the second mini quiz on the cross product of two vectors here. And so we find that if u is 4, 5, minus 2, and v is minus 3, 0, 1, and our answer ended up being that u cross v was 5, 2, and 15. So all the work for that is on the left. I'm just going to recopy this over to the right. You might wonder, how, if I get this at 5, 2, 15 as a final answer, how do I know whether or not I'm right? Well, what we want to use is the fact that this must be, or our answer must be orthogonal to both of the vectors that we took the cross product of. So we can check that 5 times 4. Here I'm doing, right now I am doing this, that u dotted with u cross v. So I guess to put it in the opposite order, so 4 times 5 plus 5 times 2 plus minus 2 times 15 is 20 plus 10 minus 30. And sure enough, that's 0. So hooray, that checks out. Now let's check to see that v dotted with u cross v gives us 0. So that would be minus 3 times 5 plus 0 times 2 plus 1 times 15. And we see that's minus 15 plus 0 plus, 1 times 15, not 1 times 5. So that gives us 0. So once again, that checks out. Hooray. So if you didn't get 0 for one of those, that would be strongly suggestive that something has gone wrong, either in your dot product calculation or more likely in your cross product calculation. And so accordingly, you should go back, check your work, and see if you can patch that up. So that was a question from mini quiz 2. Now let's look at mini quiz 3. So this was find an equation for the plane that contains the following 3 points: 1, 2, 1, 1, 2, 0, and 4, 1, 2. And so what we have to do is you have to find two vectors lying in the plane, take the cross product of those two vectors, give yourself a normal vector, and then use the entries of the normal vector, minus 1, minus 3, 0, as coefficients for x minus 1, y minus 2, z minus 1, where that x minus 1, I'm using the point 1, 2, 1. So x minus 1, y minus 2, z minus 1. Now, if we simplify this, I just said find an equation, so we are done here, but if we wanted to simplify this, we could see that this is minus x plus 1 minus 3y plus 6 is equal to 0. That last term goes away. And this rearranges to x plus 3y is equal to 7. And so our equation, x plus 3y is equal to 7, all 3 points here have to satisfy that equation. So really, what do we mean this is an equation for the plane? It means that when we plug in x, y, and z from points on the plane, then it has to satisfy this equation. So let's just do that real quick to make sure that everything that we have so far does satisfy this. So for the point 1, 2, 1, so that's x is 1, y is 2, z is 1. So we would get 1 plus 3 times 2, and sure enough, that is 7. So that checks. Our second one, 1, 2, 0, is once again has the same 1 plus 3 times 2 is equal to 7. If we plug in 4, 1, 2 now, we see that we get 4 plus 3 times 1 is equal to 7. So all three of those check out, and so that seems to indicate that our answer is correct. If we hadn't gotten 7, we had gotten 8 or something like that, that would be very strongly suggest that something has gone wrong here, and once again, we should go back to our work to double check it. Just to maybe illustrate, how something might go wrong, a very common mistake that people were making on this was that the normal vector, so let me write here wrong, lots of people had the normal vector as something like plus 1 minus 3, 0. And so then the equation for the plane would be plus 1 times x minus 1 minus 3 times y minus 2 plus 0 times z minus 1 is equal to 0. This is simplified down to x minus 1 minus 3y plus 6 is equal to 0. Or x minus 3y is equal to negative 5 after rearranging there. And so let's see once again with our points over here, when we plug in these points, do we satisfy this? Well, 1, 2, 1 is going to give us 1 minus 3 times 2 is equal to minus 5. So that is good. And 1, 2, 0 have the same effect. But what happens when we do 4, 1, 2? That would end up being, so we'd have 4 minus 3 times 1 is equal to 1, which is not equal to minus 5. And so that says something has gone wrong. Oops, I almost drew a smiley face. I want to draw a frowning face to say, hey, this point does not lie on this plane, so this cannot be the equation of a plane that contains those 3 points. So if you made that mistake, you make some mistake while calculating out the cross product here, this is how you could tell that something's gone wrong, because we don't want you to. So it's always good to be able to know how to check your work to go back and fix things. One final thing to look at, just real quick from the first mini quiz. So find a vector parameterization for a line through those 2 points here, r of t, and so what you had to do here was find a direction vector that goes from one point to the other. So minus 6, 0, 4, r of t is 6 minus 2, 1 plus t times minus 6, 0, 4. And so the thing to just realize here is that different values of t will produce different points in the line. So r of 0 will give us 6 minus 2, 1 plus 0 times minus 6, 0, 4. And so this just gives us 6 minus 2, 1, which corresponds to 1 point on the line. And we plug in r of 1, that should give us the other point that was given to us. So we can check here, 6 minus 2, 1, plus 1 times minus 6, 0, 4. And that gives us, so 6 minus 6 is 0, minus 2 plus 0 is minus 2, 1 plus 4 is 5. So we should always be able to get both of the points that we were given by plugging in an appropriate value of t. So that's just some thoughts to help you stop making mistakes, avoid making mistakes, or maybe not just avoid making mistakes, but more importantly, know how to catch something where you've made a mistake. Okay.